Welcome to the show for the third time, Mike. This is
Hey, I'm
becoming
trying to make myself a regular guest here.
back by popular demand. But yeah, look, today we are exploring AI. I don't think there's been like a conference I've been to in the last 2 or 3 years that hasn't mentioned AI in some respect.
Hmm.
It's really funny. You watch those on stage speeches by like the Google, what's his name, Sundar, and it's like every
Oh
second word is
yeah,
AI.
it's
There's
like
that meme
AI,
going around with
AI,
someone
AI,
edited it. It's
AI,
like,
AI,
yeah.
AI. Yeah,
And I was
just
like, oh my
yeah.
God. So I'm a bit conscious of like doing an episode on AI because I think it's got a lot of buzz already. But I've started using it the last couple of years. You had just written a book that's about to come out in June, I believe, on
Yeah,
prompt
actually a
engineering.
couple of weeks
And
away.
you've been
Yeah,
doing the
yeah,
speaking circuit.
yeah. I did like a book signing at the Lead Dev conference, and have a couple of events coming up as well, which is fun. So yeah, I feel like I'm finally famous, even though my rock band failed when I was in high school. I'm now signing AI books, which is great for my ego.
A rock star of other types now. Perhaps a rock star in the AI world. But yeah, look, I've been following you like last couple of years, and you've been doing the talking circuit. So who better to talk to than yourself? I mean, last time we talked more about attribution and everything, which you were at that time pretty deep in doing a project on. So we've
Mhm.
covered that. But yeah, look, I just think there's a lot of misconceptions around this. Everyone I meet has trouble using it, and it's like they'll put something in and they go, "Oh, it doesn't work," which is
Yeah.
very easy to find. And I know we've talked about this, but can we just wind back to the history? Because I think this new wave of AI, because AI has been around for a while, but I think Jeffrey Hinton, what's his name?
Oh, Jeff Hinton. Yeah, the
Yeah, yeah. I think he
Canadian guy.
sort of like
Yeah.
started the new sort of like neural net sort of wave, really, which then has really compounded and grown in a nonlinear fashion and improved like so much in just such a short space of time. I know it was just yesterday, and I messaged you using Luna. They released
Mhm.
their new, what is it, Dream something, this text to video. So it's
Yeah.
gone from like text to images to now video, which is pretty nuts. And, it's not too bad. So take us back. Like, where has this new wave come from? Where did it start? And we can go from there.
Yeah, so there's a lot of gatekeeping in this industry, just like in any other industry, like marketing. So it depends who you talk to, but I would say there's like a relatively big leap in terms of performance from traditional machine learning or statistics to what we call today like AI, like generative AI. And to explain the
Mhm.
difference, essentially, when we first had computers, you'd have to build a computer specifically to do that one thing, right? Like if you've seen the Imitation Game, you have Alan Turing, built a computer that specifically calculated this one equation, right? And it was the size of a room.
Mhm.
And eventually we got to the point where we had general purpose computers, and we got them small enough that you could have one yourself. And with a normal computer, you're writing an algorithm, or like more specifically, the programmer is writing an algorithm, a series of steps. Says do this, then do this, then do this, and then your company accounts are
Mhm.
filed. And machine learning is this kind of it's the newer thing where over the past say 20 years or so, it's really risen to prominence, where a programmer doesn't write the rules anymore. The machine learns the rules based on patterns in the data, and the machine is testing the rules. If those rules work, then they're kept. If they don't work, then they're not kept. And over enough iterations, it finally figures out a whole host of millions of these rules that you otherwise just completely unintelligible to a human. Now, where deep learning comes in, which is kind of interesting, is that they try to model how the human brain writes those rules. So they have artificial neurons, right, and neural networks, just like the brain has neural networks. So it's not a perfect simulation of a human brain, but it's like surprisingly effective, considering how poor it is compared to how our brain does it, right? So what they found, and I think this is like the real breakthrough, is this is back in the day when deep learning wasn't very popular. Most people thought it wouldn't work. Jeffrey Hinton, and then a few of the people that he then kind of taught and mentored, made a few breakthroughs, and they figured out that, hey, if you kind of use this neural network architecture, it can handle arbitrarily large amounts of data, and it seems like the more data you throw at it, the better it gets. And it's a pretty predictable curve. So we've just been on that curve, and everyone in the AI labs noticed that curve, and they just went, "Huh, if we can get more GPUs, then we can, just follow that curve, and predictably, it's just going to go from." It's the high school level to like college level to, eventually better than any human at any task, right? And they're on the curve. They think.
Okay. So let's just stop there.
So there's a lot to unpack there, but yeah, that's kind of the story of where we're at today.
I like it because you use this word compute, which is like the new oil. And I think to explain why NVIDIA is worth so much is because they're controlling a lot of the world's compute power. And compute just means like the power of a CPU or some kind of chip to like do these calculations and do this learning
exactly
as fast and as quickly as possible, correct? Or...
Yeah. And what NVIDIA figured out really early on, and they did it for graphics cards initially. Like it was, if you're a gamer, back in the day, you would buy an NVIDIA chip for your computer because then it could process all these kind of renderings and you could play video games without lag. Now, what they realized, the analogy I used for this is like a checkout line in a supermarket, right? A normal computer is like having one checkout line. Whereas, so there's a massive queue of people waiting to check out, right? So every time the computer is running an instruction, that's a person waiting to check out. And it processes it one at a time. Sure. Well, an NVIDIA GPU gives you more staff, essentially, right? So, you have maybe 10 lines, 16 lines, 100 lines, a million lines. And, that means that, more people can check out at the same time. So you can run more computations at the same time. And that turns out to be, really useful, surprisingly useful. Actually, NVIDIA were pretty early pioneers. Like a lot of the early breakthroughs from Jeffrey Hinton and like the people that he mentored were using NVIDIA GPUs. Kind of came about. I listen to the Acquire podcast on this really interesting backstory.
So good.
But they dove really deep into it. They did like a 3-part series, which I really recommend. The reason why they got into this really early on is that like some scientist he was talking to his son who had an NVIDIA GPU and to play games. And he was like, the specs on this are better than what I have at my lab. So he went out and bought a bunch of GPUs from Best Buy on his credit card. And they helped him finish his research like 4 months early. So he then contacted NVIDIA and said, look, this is amazing. Thank you so much. You helped my research. And I think that kind of early signal, Jensen, the CEO, massively doubled down on scientific computing before anyone else was really thinking about that as a category. And now he owns the whole thing, which is making NVIDIA so valuable.
Yeah. It's insane because their first wave NVIDIA, like I knew them from gaming like way back when the first ones came out, and we're like, oh my god, like I can play 3D rendering, and what it was doing at that time is that the CPU was so constrained by processing power that you need a GPU to like do all this crazy next level graphics. So they've been doing image rendering for yonks, right? So like obviously they have a step up in knowing how to specialize everything designed around just that. And because the question comes up like, why can't you just use a couple of CPUs, right, instead? And it's because like these are specialized, there's like layers of stuff built into that is just specialized into that one thing, right? But yeah, like I just find it really interesting that curve compute power is basically brute force. It's like strength of compute that allowed us to get to this next level in the AI
exactly,
race.
Yeah, it's an engineering breakthrough rather than really that many scientific breakthroughs. I mean, the transformer, you would call that like a scientific breakthrough. There's a famous paper, "Attention is all you need." But there have been scientific breakthroughs along the way, but really it's a story of, hey, let's just throw more GPUs at it, right? Which is why Silicon Valley is doing so well. Because they're just great at that. Like they're just going, okay, hey, well, everyone else is thinking, okay, what am I going to use all this compute for? Whereas a lot of the guys in Silicon Valley are already talking about, when are we going to build the first $100 billion cluster of GPUs? When are we going to build the first $1 trillion cluster of GPUs? So, they're thinking, 5-10 years ahead. Yeah, they're pretty far ahead of everyone. Yeah.
And that's why you're probably seeing some geopolitical issues here with like neon gas out of Ukraine that are used in chip production, being a bit of a important resource that wants to be protected at all costs.
Yeah,
And then the whole Taiwan thing, they want to get what is it, SMRC or what's the
yeah,
company?
TSMC. Yeah,
TMRC, TSMC or something. Yeah,
yeah.
they're like now TSMC. Funnily, I heard the story that he was a Taiwanese guy in America, and he couldn't get enough funding, and they didn't want to like create chips there, so he had to go back to Taiwan and do it there. And now it's like become such a big thing, and ironically, it's come full circle. So now the US is like, hey, build these manufacturing facilities back in the US because we need them. They're like at the core of everything this next wave, and now it's basically a fight between China and the US in terms of who's going to get AI first and control sort of the whole world's power, which is really interesting.
Yeah,
So
yeah. Well, yeah. I mean, the lesson from history
Matrix
is that
episode.
America always, does the right thing eventually. It just takes them a while, and when they do decide to do something, they catch up very quick.
They do, yeah. It's like there's a strategic resource. There's always some kind of war or like
Yeah.
forceful acquisition. It's like we need that, and we'll pay whatever
Yeah.
costs. Yeah. So I think that's explaining some of the geopolitical issues right now. But I think the first wave of Nvidia, just to backtrack a little, with their GPUs was for Bitcoin mining and crypto mining, and that's sort of gave them
Weirdly,
that huge wave, and then that's sort of the next wave.
Yeah, weirdly, they, the gaming PCs was one thing, and then they started to sell out GPUs for crypto mining. And then when crypto crashed, they had all this excess capacity just at the right time. And I feel like the early pioneers in AI probably massively benefited from that, right? But it means that they were so far ahead of everyone else in production, right? Because they had already scaled up for crypto.
Yeah. Okay. So we've hit this new wave. The compute power is coming. Nvidia's like rolling in it. And then we've got the sort of the first. I would say there's been a lot of people working on these projects, like university, the things, private AI things. I know there was a big wave of like every startup was AI, and then it sort of died off a bit because they found out how hard it was. And then sort of SaaS took over a bit, and that was big. And now I find, what was it, 2019 or something, that ChatGPT sort of 3 came out or something, 2 or whatever. Like, can you run us through like the next wave? Because now it's becoming sort of accessible to the consumer, whereas before it was very much like a niche sort of B2B thing or like in research labs. So when did that start, and who started it?
Yeah, so GPT-2 is when I started to hear about AI being like worth looking into. And then I was at the time I was leaving my agency. I left in 2020. And that year got access to Copy AI, was the first kind of experience I had with GPT-3. They had been building it on GPT-2, which could barely string some sentences together, and was open source. GPT-3 was the first one that was closed source. That OpenAI was like, oh, we've got something here. And they started to sell API access and things. So those guys got API access really quickly. I got access to that, and I was like, I remember I was on holiday, and my wife works in journalism, and I was showing her, and she was like, her reaction was not like, "Wow, this is cool." She was like, "Oh, this is terrifying." It's like I can kind of see this, like, what am I going to do in 5 years? If this keeps getting better.
There's also like Jarvis.ai. I remember using that early as well. It was like Copy AI and then Jarvis, and then there was a couple of other iterations, but a very quick succession. And so this is because this comes up a lot, like what is an LLM? And there's different sort of there's open source ones now that are a bit like smaller sort of models, and then for the bigger ones you've got to pay money because they cost more or something. Can you explain the difference there? Because there's lots of models going around. What's the difference between these different ones?
Yeah, so because we're on this curve, the models basically get like twice as good and half the cost, every 6 months, right? So the models that are coming out today that are small enough to run on your phone, like the new one that Apple announced, they are already better than the best possible model was 2 years ago. So things that were like state of the art 2 years ago, essentially you can assume that like it'll be small enough and cheap enough to run on your phone, a few years later. So that's kind of the curve that we're on. And so GPT-3, I remember I used a lot, and started to automate a lot of my work. And then when GPT 3.5 came out, which was basically the same model, but really trained to behave, trained to be a bit more useful as like an assistant rather than just a raw model. then that was what powered ChatGPT, and then we were off to the races, because that was the first major consumer application where it wasn't just an API that us nerds were playing around with. People could program.
Yeah.
Like suddenly, people who could, it was a model that actually did a good job that like regular people could try. So they quickly got to 100 million users very quickly. Yeah.
Yeah, it was nuts. And I remember prior to that, because us nerds had access, right? Like API access. I remember that sort of what killed really social media, because suddenly a lot of the tech people or people who had access to the stuff could create 100 viral Twitter tweets that they could then queue into the system and know they'd be pretty successful, and then you had these sort of these content niches like Topilio and like Tweet Hunter and stuff, aggregating the stuff, and then you can kind of do iterations of it at the push of a button, like basically automate your social media. I remember people using that, and then all these other users going, why are they so popular? Like, how do they, tweet so many successful things in a row? And I'm like, yeah, well, there's some tricks happening in the background, you know what I mean? Like, and I remember that happening, and then that really killed social media algorithms, and they really had to put the quality filter parameters really high, which has killed all the organic reach, right? But I remember them having to counteract that force because it was just so good, and there was this separation between the two people. Okay, so ChatGPT comes out, and then it becomes consumer facing. Everyone's like, oh my god, this is so good, I can kind of do anything. What is an LLM though, before we sort of go to the next thing, which is GPT-4 or whatever? What's an LLM?
There's two major kind of infrastructures that are being used, right? So when you talk about text models, that's a large language model, LLM. You also have diffusion models like Midjourney, DALL-E, Stable Diffusion, and they're the ones that generate images. And actually, everything's kind of converging on LLMs, because the newest version of DALL-E is supposedly it's a diffusion model embedded within an LLM, right? Same thing for Stable Diffusion, the newest model of that. So everything's kind of converging. So what is an LLM? It's really just an architecture that they've figured out. They can throw a lot of data at, and it just can take it. And the way it works is they chopped up the whole internet, right? Basically scraped the entire internet. The problem with these models is how do you know whether it's doing a good job or not, right? How do you teach it? That you did this well, you did this badly. But it's too expensive to do that for early training, because you'd have to hire millions of humans to teach it, right? So what the trick they pulled was, hey, if we just take every sentence on the internet and we just chop off, say, the last word, and it's done a good job if it predicts the last word. And this is a really elegant solution, because now you don't need to really do you don't have to have a human review that data, right? Because it can automatically tell whether it's done a good job, because what that last word actually was, right? So now the really interesting thing that happened, and this was the unexpected part, is that just by telling it to predict that last word, it basically had to learn a lot about how the world works, right? So it seems very simple, it just predicts the last word, LeBron James threw and then it would be a ball, right? Because he's a basketball player, right? That's a pretty easy prediction, but in order to make that prediction, you have to know who LeBron James is. You have to know he's a basketball player. You have to kind of know a little bit about how the world works in order to make that prediction. So by giving us a quite simple task, and you do that hundreds of millions, trillions of times, then it just reverse engineers physics, language. It can translate between any language, data structures. It can learn how to code. It's kind of crazy how many different things it's already capable of just from that one trick.
Okay. So what's a diffusion model then? Because you said there's LLMs and then diffusion models. So what's the difference?
Yeah, so diffusion models are used for image generation, and they're smaller, and they're training on lots of images, but the way that they operate is slightly different. A similar type of concept, but what they do is because obviously there's no words in an image, right? So you have pixels. So what they do is they say, okay, if you take an image and then you add noise to it, so you make it fuzzy, right? So you have a high quality image and you make it fuzzy,
Yep.
and then you just see if it can predict the real image from the fuzzy image. So see if it can remove noise from the image, right?
Okay.
So that's what it's learning to do. So it turns out if you do that enough, you can eventually get it so good that you can give it random noise and tell it this is an image of, Donald Trump on the moon, whatever, and it will remove the noise until, so it's like, that famous Michelangelo
It's the same kind of thing. Instead of the last word, it's like find the next pixel kind of thing, right? That's like
exactly.
In the pixel hole
because it has some of the pixels because there's noise, right? But yeah, it's like the Michelangelo quote. I think it was him anyway. When how do you carve a statue? I take a lump of rock and then I chop away anything that isn't the statue. That's kind of like what they're doing with denoising. It's like I just give it random noise. You say just chop away anything that isn't the prompt.
That's funny because I remember doing sculpture in art class. I think it was in high school or whatever, and I found it really hard because you had to think backwards. You had to think where's the point closest to the subject, and then etch away. So it's basically like painting. You're kind of adding layers, and like you're crafting something from inside out. And sculpture was the complete opposite, and I found it really hard because if you etch away too much, like there's ends up being flat, and then everything kind of looks weird, and you're losing the depth. And that's why I found it really interesting. So completely get it. Okay, so got diffusion models, got LLMs. Now ChatGPT comes out, everybody's using it. It's like $20 a month, whatever it is, and people are then using DALL-E. So can you just tell us all the different brand names out there? Because I think it's really good to get a lay of the land. There's some open source models, meaning they're kind of free and you kind of build upon. Like I know Facebook's Llama is somewhat open source. And then there's more ones that are closed source, like OpenAI, where you've got to pay or there's a limit on the usage, that kind of thing. So what are the big players right now as it stands?
Yeah. So it's obviously changing every week, but the major kind of genesis of this is OpenAI was way ahead of everyone for a very long time, and they're really the only player in town. And that has remained true mostly in LLMs. Actually, like it's only really recently that there were other players that was serious enough to challenge them. So I'll cover that in a sec. But like the really interesting one was the image space with diffusion models, because I feel like the innovation happened a little bit quicker there. And it is like probably what's going to happen with LLMs. I think it's going to play out the same way. So in the image space, OpenAI released DALL-E. This was in 2022. I tried to get access, couldn't. It was on the wait list. I'm not in Silicon Valley insider, right? So I signed up to Midjourney, and it was kind of crazy because people were like, DALL-E, when we saw it, the images were unbelievable. It was like, wow, this is magic. I can't believe you can type in like a picture of a cat and it generates a cat, right? Like this was crazy to me at the time. I thought I really want to get access to this. Midjourney came out and everyone was like, there's no way that like, some random bootstrapped startup, I think they're a team of 14 people, has made anything close to what OpenAI has made, right? Like nobody expected that this would be possible. And the funny thing is like they opened their waitlist up really quickly. I got access. I think it was May 31st. I just looked at it recently.
Because they're on Discord as well.
Exactly. And they had a really weird model. Like they're on Discord. So, the only way you could use the model is if you like send it a message on Discord, which just, again, made it extra nerdy. So they kind of flew under the radar. But it was one of the reasons why I thought, oh my God, this is going to be a very big thing, is that they very quickly, like, I remember like every 6 months where they're adding 5-6 million people to that Discord. So I think it's well over like 15 million people now, which is bigger than say the Fortnite Discord. It's bigger than all the gaming communities. It's bigger than the crypto communities. So I was like, okay, this is definitely a thing, right?
Yeah.
So not only was it a huge shock that someone without OpenAI's $1 billion of funding could make something as good as DALL-E. But they actually iterated quicker and became better than DALL-E for a long time. And then the really surprising thing was Stable Diffusion came out. And this was a real shock because not only was it like as good as Midjourney and DALL-E at the time, but it was open source. It was free, right? I could download it and run it on my computer, right? And I think that's what really blew open a lot of interest. That's when all the people on Reddit were playing around with these things. Obviously, inevitably, people started making porn with it, which is where a lot of the innovation came from, which the industry doesn't talk about that much, and it just, because it was open source, it just got better a lot quicker. It had a lot more features. People invented new techniques. So in a lot of ways, it's kind of instructive because we haven't had that stable diffusion moment yet in LLMs. In LLMs, you have OpenAI still has the lead. Anthropic is the nearest competitor, like the Mid-Journey of the LLM space. Smaller team, more personality, less kind of corporate overlord vibes, and not aligned with Microsoft. So they were kind of almost there, and we have Llama 3, which is open source, but it's not as good as Claude or which is the Anthropic's one, or it's not as good as ChatGPT, right? So Zuckerberg is kind of the savior of the open source community. Like people are praying, worshiping him because he's currently training a model there's going to be 400 billion parameters. The current one's 70 billion, so it's going to be much bigger. And that version of Llama might be the stable diffusion model, equivalent. It might be that moment where suddenly we have an open source model. We can run it on our local computers, potentially, in a few years, and then we're really off to the races, I think.
Okay. So just to summarize, then we've got a stable diffusion, which I know there's some finance guy that's sort of taken over that, and there's some weird stuff.
Yeah, the company has kind of imploded. Cool. Yeah, the actual company that pushed it forward has imploded. but that's the nice thing about open source is that it doesn't make a difference because we've all got it on our computers now, and we're improving it regardless of what the company does.
Okay, so we've got Stable Diffusion, we've got Mid-Journey, we've got Claude by Anthropic, we've got Llama by Facebook, we've got ChatGPT or GPT 3, 4, or whatever by OpenAI. And then now we've got Google Google Gemini, I think it's called, and there's some other names or whatever.
Yeah, Gemini.
Do we have any other sort of big players here or not?
Yeah. So another one to know about. To be fair to Google, I think they have a lot of latent kind of pent up abilities that haven't really been fully deployed yet because they've been a bit slow to the mark. But they have their own chips. They have a separate type of chip that isn't the same as NVIDIA's. They have so that's a huge advantage. They're not going to be constrained like other people might be.
Heaps of data.
Heaps of data, heaps of money. So even though Google is behind, I suspect it won't be for long. Now, the other one to mention that is pretty interesting is there's Mistral, which is a French startup, and they've also been open source. And they made a big splash. Again, very small team. They released this open source model, and it was suddenly almost as good as the worst version of ChatGPT,
I heard they just got some extra funding yesterday because they got some big sponsors like Andreessen and Sequoia. I think are raised that round recently. They just raised 300 mil or something crazy. So they're one of the big European ones.
Yeah, exactly. Yeah, and I feel like there might be. I mean, it's great that they exist because one of the biggest dangers of AI might be if the EU massively overregulates it. The nice thing about Mistral, I would say that's not necessarily a danger to AI; it's a danger to the EU because can you imagine being left out of the internet, happening, or being left out of the printing press or something? So now that they have a national champion, and they're actually pretty cool. The insiders, think they're good. So it's they're their vibes are immaculate, so they're actually really well respected, and the chances are they'll release a GPT-4 level open source model fairly soon as well. So I think now that the French have this national champion, that's actually probably maybe one of the more beneficial things that could happen is that because they're doing a good job, maybe that will stay the hand of the EU and mean that Europe is along for the ride, which is going to be really helpful, I think. because we don't want it all to be just
Okay, I
completely
love it.
dominated
So
by
just to
US
recap
and
then,
China. You know?
oh, no, I think it's a bad thing. So we've got so we need compute power, which is the GPU or CPU kind of power to train these models. Obviously, we need lots of data sets, which is where this like privacy thing comes into play, because like, and I think this is
Yeah.
why Google's behind, is because they have like more of the world's data than anybody else, right? But they can't like explicitly use it because of like
Yeah.
previous privacy policies and that kind of thing. So I think they have the most potential, but probably it helps explain some of the misses they've had recently is because they're actually trying to protect some of these agreements. And then
Yeah.
obviously Facebook has pictures and videos and text, so they're on a winning wicket there with like crazy amounts of like the world's data as well. So you need compute power, you need the data inputs, and then you train your models, and they get better over time, and you just basically need raw power to sort of make them better. Now, we've got text, we've got video.
You're kind of missing
now,
one.
We've got...
Yeah, sorry. You're missing one key
Okay.
component, though, is the talent, actually. So that's like kind of adds another dimension to this. It's really interesting because today, like as a developer, you know, you can make a lot of mistakes, right? Like if I'm building a web app, like I'm building a website, I can code it. If there's errors, I can code it better. I can run tests. If it passes the test, whatever, that's fine. So coding right now is an iterative loop, and it's trial and error. And it's very fast, very easy, very low cost relative to like, you know, in the past. Well, because AI is so resource intensive, because those GPUs are rare and expensive, and because getting access to those GPUs, like you better have a good reason to be using them, right? Because if you're messing up, like if you run your code and it breaks, then you know, at the end of the training run, then you've just wasted all those cycles. So I think this is maybe an underappreciated part for people who aren't as technical. OpenAI has all the talent. So when they do a training run, like the people on their team just have better intuition for what's going to work. Because they're more experienced and because they're like really super ambitious, and you know they came into this really early on, so they have better intuition about what's going to work when they run it. And there's only a few places in the world where that type of talent congregate. It's OpenAI, it's Facebook, and it's like Anthropic and you know, those sorts of places. So
because
that's the key.
I saw their revenue was like 3.5 billion ARR now, something like making lots of money. So obviously some of the talent that's there have like shares or employee share options. So like there's a big buy-in there, which helps explain why perhaps Sam Altman, albeit for all his flaws, and like Helen Toner's investigation. Well, she disclosed what actually happened. I was like, oh my god.
Yeah.
Like he released ChatGPT without telling the board. It was like, what the fuck? Like, anyway, so he's obviously got like a lot of talent locked in with employee share options and that kind of thing that vest over time, and then obviously it's an interest. They're making lots of money, like billions ARR, which is big, which feeds
revenue,
so like,
but not not profit yet, probably. Yeah.
No, of course not. But I mean, it does help compared to an open source program where like, it's free or something. Obviously you're going to attract better talent. It could be quicker cycles, better improvement, better quality. So cool. Okay, now we've got the Kling that I saw the other day, a Chinese text to video thing. We got Sora, which came out 2 months ago or something. That was crazy, which is the video one. And then we've got Luma that just released their text-to-video one as well. So is that like a diffusion model, just that in motion? Like, explain what these are.
Yeah. So we did text, we did images, and now people are starting to explore other modalities, right? So audio is another one, like Juno AI. I don't know if you played with that. It's really fun. Really good. Like you can tell it what type of song you want, and it will come up with the lyrics. It will generate. So I use that one quite a bit because I like make songs for my daughter. Like I made she wants like a Taylor Swift song.
Or for I've seen it for like on
stage, she did that day, like speeches.
I've seen people use it on speeches, like before they come onto the stage, just like they just create some kind of track or whatever, or like for the start of podcasts like this one. Actually, let's do it. Let's put AI into this thing. So I'll edit this later, but you'll probably hear like an intro track. So let's create some AI stuff around this.
Do it. Yeah. So audio, and then you also have text to speech. So if you're there's 11 Labs, which is the one I've used, but OpenAI has something as well where you can type in some text and then give it a voice, and then it will start talking. So this is the with OpenAI, they got in trouble for using Scarlett Johansson's voice, or actually technically someone who sounded like her, right?
Yes.
Yeah, and then you also have audio transcription. So that's kind of a solved problem now. You can take any kind of podcast, transcribe it into text, right, to get the text out.
Yep.
So what you're finding is
regularly.
Yeah, exactly. Yeah, you're using all of these tools, like they're all kind of converging, and GPT-4o is the first glimpse of that. I think from a strategic perspective, GPT-4o isn't multiple models where like one transcribes the audio. Like when you talk to ChatGPT, it used to be that you would talk to it, it would listen to the audio, and then it would turn the audio into text, and then it would take the text, and then return more text, and then it would turn that text, its response, into audio again, and speak in Scarlett Johansson's voice, right? So that's kind of how you would build this type of tool. You would string all these different models together, and then when you ask it for an image, it's actually calling a different model, the diffusion model, and saying, "Hey, make me an image of this. This is what they've asked for." So GPT-4o is the first glimpse. They're all kind of converging, where it's a multimodal model, meaning they take in any type of input, and then that kind of goes into, you can think of it as the AI's brain, which will trigger some neurons somewhere. And then those neurons can then fire any output, right? So you can take any, image, text, sound, whatever in, and then give anything out, right? So that's one of the trends. Now, the video models are still kind of a new modality. They're not quite integrated into that format yet, but they will be in the future. The way the video ones work is slightly different right now in that they need, if you think about it, a video is just, lots of images stacked together in a way. It's like if you have 150 frames a second, that literally just means it's like 150 pictures every second, right? So it's a lot of data, but it's not like, impossible to handle. So again, you just scale up the GPUs. Eventually, it gets to the point where it can generate 150 images faster than we can see them, right? And then it can create a video. The way that it does it technically is a little bit different, in that they call them patches, rather than diffusion, which is the pixels, rather than LLMs, which is the tokens, the text. These patches are basically like parts of the screen, where the way they do it, you can kind of track, like, okay, there's a car moving across these images, so it knows which patches to predict, like what patch it's going to get into next. If the car's moving from left to right. So that's really important. That was like kind of the last thing they needed to figure out for video, because it's not good enough to just generate 150 images if people are jumping around and it's very jerky motion, right? Like you need it to be smooth motion. You need to slightly understand physics, right? Like if you throw a ball in the video, like the ball should come back down in the right place.
Or like fur, that was kind of the last, the fur or the clothes, like.
Exactly.
Okay,
or
cool.
like
So,
there's like a Storm in a
awesome.
Teacup example where they had a pirate ship in a cup of tea, and it looked realistic, right? So I think that was kind of the last unlock they needed, and in the similar to text and images, now you have like OpenAI's model Sora, which isn't released yet, but it's supposed to be amazing, and then you have some of these kind of upstarts who have also cracked this at the same time, and they're kind of going, hey, you can use our model straight away. So Luma Labs in this analogy is like the mid-journey in the scenario, right? Like OpenAI hasn't given anyone access to Sora yet, but like Luma Labs you can use straight away. So I feel like I'm kind of bullish on them. If they don't mess it up, I think they could do pretty well.
Obviously, to use these models, this brings me to the next thing. Before we get to that, though, there's this data privacy thing. So I know some businesses that I'm talking to, whatever. They're like, hey, like legal firms, etc. I've got a lot of data, like personal data on storage, on cloud servers, that kind of thing. And they're going, okay, can we use that to, especially like help desk or internal documents, whatever. Can we use an AI to then like easily query that or repurpose that into articles or this or that or whatever, right? But obviously there's some privacy considerations around like where does that data go if it's really sensitive, which models can I use because I don't want, this company is getting this really sensitive stuff. So what are the sort of use cases there for some of these larger businesses that might be sort of playing around with it, and what would you sort of recommend there?
Yeah, good question. So when we start talking about use cases and like using your data in the model, there's a lot of misconception. And the way I describe it, I think some of the misconception is on purpose, right? Like I've worked with vendors who they say they're like training the model in your data, and they're not actually changing the model. They're still using the same OpenAI model underneath, but what they're doing is they're putting your data into the prompt that they send to OpenAI, right? So they're not actually training anything, right? Like they're just kind of misusing the word to make it sound, fancier so they can charge more. But there's a few different ways to think about this, right? So I like to give the analogy of humans, like of people going through the workplace, because I feel like this is an easier way to understand it. So you have pre-training, which is, if you think about the millions of years of evolution that got us to this point, there are certain things our bodies know how to do, right? There's certain reactions that we have to our environment that are pre-programmed in. We've learned them through millions of years of evolution, being alive on Earth, right? And those are kind of like biological, right? So when you train the new version of OpenAI, like GPT-4, GPT-5, that there's a pre-training step where they take all the information from the internet and it learns to derive like how the environment works. So that is our equivalent to biology. Then you're born, and then your parents raise you, right? And what your parents do is they tell you, no, don't do this. Yes, do more of this, right? And you do that enough times over 18 years, and hopefully like a fully formed citizen pops out, right? That is, that isn't going to go to jail and, is going to do good things, helpful, useful things for society, right? And that's called, the equivalent in LLM terms is RLHF, reinforcement learning from human feedback, which is the difference between GPT-3 and ChatGPT, right? ChatGPT is much better at following instructions than the raw base model, and to the point where like they didn't even let you use the raw base model anymore. Now, whenever you use a version of GPT-4, GPT-5 onwards, it's not a baby. It's an adult that's been raised by good parents. You can think about it that way. And then you go out to the world of work and you get a job. And on your first day on the job, they say, okay, here's how we do things at our company, right? Here are our standard operating procedures. They might give you on-the-job training to say, here's how we do this task. Well, the equivalent in LLMs is the information you put in the prompt. So you're not actually training the model, right? There's nothing, your DNA is not changing, right? You're still the same person, but you're getting more context on how to do that task. And that is the way that most companies will and should interact with these models. Is like, don't worry about making your own, new model from scratch. That's going to cost billions of dollars. Don't even really worry about fine tuning, training the model weights, because that's like the equivalent of raising a new child. It's still relatively difficult and expensive. What you need to worry about is like, take a already well-raised child, which is ChatGPT, and put your context for that task, like the thing it doesn't know anything about your company, right? So if you can give it the standard operating procedure in a document and say, here's how we do this task, and it's got that in the prompt, then it can do that task much better according to your specifications. So all of the kind of hype around using ChatGPT with your data, etc. It's all about just stuffing that into the prompt. And the nice thing is we've had a lot of innovation in this space as well, where used to be you could only fit 4,000 tokens into the prompt, which is a token is about 3/4 of a word. So it was like a normal like a blog post, right? You could fit in, and that was about it. Whereas now the standard GPT-4 I think can fit 120,000 tokens, which is about the size of a Harry Potter book. So when you talk to ChatGPT, it could fit that much information, like a whole Harry Potter book worth of information, into the prompt, and then give you a relatively good response from that. So that's the delineation there. Most AI work is, most prompt engineering. What I'm doing is not like training you a new model. It's really just like finding clever ways to put the right information into the prompt.
Okay, cool. So this brings me into prompt engineering.
Yeah.
I know you spoke about this recently about the misconceptions of exactly what that is, and
Mm.
some people think it's like, oh, here's some queries that you can shove into ChatGPT and it'll spit out a really good answer. You know, see these people on Twitter and LinkedIn like, hey, steal my prompt. Tell us from your perspective, what is prompt engineering?
So if you think about, like, if you keep going with this analogy, if you're hiring an employee, you need to give them a brief on how to do the task, right? And the way you write that brief can make a massive difference to how well that human does at the task. Like if you're hiring an agency, you give them a really poor creative brief, you're going to get really poor results, right? And the same is true with ChatGPT. The way that you word the brief, makes a massive difference to the type of results you get. So you can think about this as getting good at brief writing. And unfortunately, as we know, working in marketing and having been on the agency side and client side, nobody can write a brief, right? So that's what prompt engineering is I'm basically someone who's just really good at writing briefs for ChatGPT and DALL-E. So that's how you can kind of think about it. Now the difference is what I really love about this, and why actually I've kind of moved away from marketing and work full time in AI now, is that in marketing, you get a chance to write a brief once, and you don't even know if it was your fault because the brief was wrong, or if it was the agency's fault because you hired the wrong agency, or they're having a bad day that day and they just didn't read the instructions. There's millions of reasons why something could go wrong, and you don't get to A/B test it, right? It's you don't get to hire two agencies, give them or you don't get to hire 100 agencies, give 20 of them one brief, 20 of them another brief, right? You can't do that in real life. But with prompt engineering, you can. I can hire 20 agencies, right, to do a task, but the agency is ChatGPT, and then I can give it 20 times one brief, 20 times another brief, 20 times another brief, and then I can just measure, okay, how often does it get it right if I word it this way versus if I word it that way.
And that's kind of what you're describing about engineering, which is like this sort of test and learn architecture behind the actual, what we'd call, text prompt that goes into it. So you're engineering that sort of structure and learning and developing and training these things. So that's
exactly. Yeah. And where it becomes engineering rather than just prompting, in my mind, is when you're doing it at scale. So if you're just chatting to ChatGPT and it's a task that you're going to do once or twice, you don't really need to think about prompt engineering. Where it becomes important is if you're building an AI application, like a feature in your product that uses AI, or if you're templatizing a task that you want the AI to do for your team every day, every couple of days, then it's really important to know that 1 in every 100 times it says something racist, or 10 in every 100 times it gets the brief wrong. So the key task that I'm doing as a prompt engineer is very similar to the types of things I was doing as a growth marketer, which is defining what does performance look like, how we're going to measure performance, because that is this whole thing, both in marketing and in AI, because most people don't know how to measure performance, right? So it's a lot of hand holding to get to that point of what's our definition of whether this task has been done well or not, and then doing the task multiple ways, like testing all those different briefs, all those different instructions, and finding ones that perform better against our evaluation metrics. And then when you're really failing and you've tried multiple combinations of it doesn't matter how I say it, it's still not doing a good job, then finding ways to, clever ways to give it more context. So, hooking it up to a search engine so it could do a Google search on your behalf to get the right context, or, hooking it up to a database which has all of your company documents in it, so it can search for which documents are most relevant to this query. That sort of work. So that's where it becomes engineering rather than just finding the right magic combination of words, which is just prompting. Yeah.
Okay. So for most people who aren't engineers listening to this, or who aren't architecting these kind of things at scale using APIs and that kind of stuff, right? And most people would just be interacting with the default window or whatever, which is like a text prompt, right? Now, I've seen a lot of people using it for the first time, or maybe not as experienced as you, going, "Oh, I put this in, it came back with this rubbish." Oh, AI doesn't work, right? I've had this a lot, especially from boomers. But I found that the quality of how you contextualize that really matters in terms of the output. For example, I noticed a trick after reading some of your stuff is like tell it what it is first before you tell it what to do. So you are a graphic designer.
Yeah.
I am hiring you to create me a logo. This logo, I like these colors and this kind of style. Can you give me a couple of things and then we'll refine it from there? Very different to if you go, create me a logo that's like this word in green. You know what I mean? It's going to come like something random that doesn't even have the words in it. So can you just tell us like what are some sort of basic rules here if we're doing prompting ourselves to go through to get a better quality output?
The people who say that, I think it's like the equivalent of someone who, like, if you hired a new employee and then you didn't give them any onboarding, you didn't give them any training in your company, you didn't even tell them what you want, from the task, like you didn't give them a brief, and then you go, they've done a bad job here, therefore hiring employees doesn't work. Right, with it completely ignoring the evidence that there are like plenty of companies out there who have found hiring employees to work.
Like most managers in every company.
Yeah, exactly. Yeah. So I mean, if it's working for other people but not working for you, then maybe the right take is not that AI doesn't work, but like maybe we're just not using it correctly, right? Or maybe it just doesn't work yet for your use case, because I found plenty of things where I'm like, I struggled, spent a few days on something, didn't get it to really work up to my standard. But then, 6 months later, the new version of the model comes out, and no, it can do this without any faff, But I think one of the big blind spots I'm seeing with people is self-preservation. And I saw it with myself as well. And I actually only accidentally broke that loop, which is what really led me down this path. So let me explain what I mean by that. You don't want AI to do a good job at the things that you do, right? Because then if it does, then what's the point of you being here, right? So whenever you're evaluating a task that you do yourself, and you're looking at AI and you go, no, it's not doing a good job. Like maybe try and be a little bit more honest with yourself and try and do like more of a blind test with other people who aren't you to see which ones do they really prefer. So the reason why I started running these blind tests is I had this when I was delegating to employees when I was building my agency. I was, one of the major things that I was really good at, I thought, was writing blog posts to grow. And that was like 60% of our leads came through our blog. And I was really reticent to like hand that over to someone. And what we did is we ran an A/B test. He wrote 6 blog posts. I wrote 6 blog posts. And over the course of those few months, he got the same amount of traffic for his blog posts and the same amount of leads that I did. And I thought, God, I'm so wrong about this. Even though I thought his posts were objectively worse because my ego was telling me that, I was ready to be replaced. Like, and great. Like if I can, stop writing blog posts, it's saving me a day every week. So that I fully handed everything over to him. And I had the same experience with AI where at first I was like, I can't really use this to write my content. Can't really use this to automate this task. And then I had an accidental situation where I was working on a blog post with a client, and they had access to the Google Doc. And I woke up in the morning and they had commented on it all. And I was like, oh, I hadn't even looked at this. I had just generated it from ChatGPT. And I was copying and pasting stuff into this Google Doc. I didn't expect the client to review it. I was going to go through it and like actually make it sound like me, and actually like improve it.
They thought that you wrote it.
They thought I'd written it, and the really the thing that bummed me out was they actually gave me better comments. Like they were happier with that work than they normally would be. So I had to tell them obviously what had happened, but I was like, okay, yeah, maybe I need to do more blind tests. So one of the things I do in workshops now is I'll ask them to give me some tasks that their team does every day that they're struggling with, they can't get AI to do, and then I'll use my prompt engineering to try and replicate, like, can I get AI to do that task with the same context that the human was given, and then I do a blind test and I ask them to say, okay, which one do you think was AI and which one is better? which is key. Because the funny thing is that a lot of people can tell which one's AI now, but usually it's because the AI is better. But like it's really interesting for the people to see, like, oh, like I thought my version was much better, but like actually 60% of people voted for the AI one, in some cases. So I think once you see that, it kind of creates a big unlock in your brain. You think, okay, maybe I'm just kind of being harsh on AI because I don't want it to be better to me.
So step one is like this unconscious bias against AI, right? And this is funny you mentioned this because there's that famous, not Ermo Bass, but like Byron Sharp is one of the 4 authors in it. I think Kennedy, Sharps, and 2 other people. They did this test of to experienced marketers. Hey, choose which of the 2 ads produced a superior revenue results. And basically experienced marketers only have a 2% chance over 50%, meaning that it's like within the margin of error, meaning that like experienced marketers are no better than flipping a coin. And agencies were like negative, like 47%, so they're like worse on average
worse
than anyone else. And I'm like, hang on, this is like one of the biggest lies in the entire marketing industry, that there's somehow this agency or this experienced marketer do a better job in terms of advertising creative than anybody else, that we must hire them and we must hire that really good agency because they're better. And like, they're not when it comes to revenue. Maybe in terms of political optics and that kind of stuff, but when it comes to bottom line results, no. Therefore, it's sort of like that's a really hard thing for a lot of marketers to like think about, that actually my experience means basically nothing.
Yeah, 100%. Like, and we saw this with our agency as well. Like, we used to keep track of every experiment we ran because we're a performance agency, and we had a database of 7,000 experiments by the end before I left. And what that told me across all clients, we had 200 clients represented in there. Small startups as well as big companies like Booking.com, Nestle. And what we found was we would have a test success rate of 35%. So if you think about what needs to happen before you put a test live, it's it's a new version of a campaign, like a new creative, a new landing page, new email, whatever, that you think is going to perform better than the one you have, and then you send it to your boss, the strategist, and the strategist thought it was going to perform better, so they approved it. And then the strategist pitched it to the client, and the client thought it was going to perform better, so they approved it. And in some cases, the client's boss, right, like if they need approval. And then so all of those people thought this was going to work, and even with the collective wisdom of that crowd, they still only got it right 35% of the time.
Yeah, and I love that. Okay, so subconscious bias. Now, so there's a bit of a learning phase. Is kind of the longer answer to how I said how not to prompt badly, right? So give it context, that kind of thing. Is there some like really quick pointers you can give the layman here in terms of like, okay, a bit of a training phase, so expect that. Try to get rid of your bias. What else? Some other pointers that we could tell people to get more out of these programs.
So because we just wrote a book on prompt engineering for O'Reilly, and it's going, it's in print, so which is like maybe a terrible idea because everything changes in AI every week, and we didn't want the book to be out of date the day it was published, right? So so what we did was we kind of zoomed out and said, okay, what are the principles? Like, forget about the tricks and hacks and tips that you see on social media. Let's zoom out. Like, what are the main principles of, like, here are the categories that they worked 4 years ago, 3 years ago. They're still working today, and we think that they will continue to work in the future. And it actually ends up being a pretty small list. It's five things. And you can run down them like a checklist, right? And we based the whole book on this. The first one is give direction. So that's the briefing part, like that's the role-playing part. So like, as Steve Jobs, come up with a product name, right? You're going to get very different names. So if you say, as Elon Musk, come up with a product name, right? So giving it some direction of what's the type of style that you want. That's the first one. And then the second one is specify the format. So it makes a big difference as to what format you want this response in. Like for image generation, do you want this as like in the format of like a painting, or do you want it as like a product photo, or do you want this to look like a video game? Like
Or an
there's all these
English
different
sonnet or
formats.
something.
Yeah, exactly. Yeah, and then same thing. Like this is if you're building AI applications, it becomes really important that the text that comes back is in a format that the developer can pass and use, like JSON. Then the third thing we usually move on to is providing examples. And this is the biggest, most impactful thing you can do, but it takes a bit of time because you have to find good examples of the task being done. So, if it's doing a bad job, if you've given it some direction, you specified what format you want it in, and it's still doing a bad job, that's the biggest thing you can do is like go and write some examples of this task. Like do the task manually a few times, or find examples on the internet.
Or upload the image of something.
Or upload an image of something that you want to kind of replicate, and then it's going to do a much better job. Actually, it makes such a big difference that in AI research they differentiate it. They say, how well does this model do zero shot, which is no examples given, versus few shot, which is a handful of examples given of the task. So that makes a big difference. And then those are the three things you kind of do to improve the prompt. But then you're kind of thinking about how do we improve the system. So then the fourth is evaluate quality. So don't just run it once or twice. Run it 10 times. You can just hit regenerate in ChatGPT. You don't necessarily have to be a developer to run it a few times. Okay. So run it 10 times and see how often does it get it right or wrong. Because it is probabilistic. You don't get the same result every time. And sometimes it might fail, and you don't want to kind of rely on that. Then the fifth principle is divide labor. So just like in our economy, right? Like you work as a marketing consultant because you're very good at that. You're actually good at a lot of things. So maybe it's a terrible analogy, but I probably wouldn't hire you. Like I might hire you to tell me what champagne to drink, or you might be good at baking or whatever. But like maybe you're really terrible at pickleball, right? So you don't play pickleball, and somebody else plays pickleball because they're maybe more interesting to watch. So same thing with AI. Your different prompts. You don't want to try and do everything in one prompt. Quite often you want to split it up into multiple tasks. So in generating blog content, for example, don't ask it to create a whole blog post with one prompt. You can ask it to write some titles, and then you can ask it to write an intro. And then after the intro, you can say, okay, write an outline for what the body copy should have. And then you say, okay, write section 1 of the outline, write section 2 of the outline, write section 3 of the outline. And then you might have write an outro, generate an image for that's relevant to this blog post, and then you might even say, okay, now rewrite it in my style. Here's my style. So you can have multiple steps, as part of that one thing, and typically you get better results if you split things up.
Yeah, I love it, and that sort of brings me to some work I was doing with some of that, around agents. So you create specialized AI agents that are specialized in these tasks. So for this example, it was like marketing research. So we'd have like someone who was like the qual person or the quant person, someone's the architect of the study, as someone that was analyzing the results, and they specialize, you train them all together, and then you create this like hive of these AI agents together that actually work as this really team, which is basically emulating what professional services does anyway. Like we can't be good at everything. So like you specialize and then bring it together as like a hive. And the results from that were just like amazing. They're like way better than some of the best teams to work with, which is pretty scary. Actually, I really like that. Point, you've got a book that is on prompt.
Sorry, I just wanted to raise this because I saw it and thought of you. Do you see that Mark Ritson came out massively in favor of AI yesterday? He's invested in synthetic data.
He's invested in the business.
Yeah. But I mean, to be honest, it's actually a legit idea because I've done this myself. But what they do is they spin up a bunch of agents, right? And those agents represent the demographics of maybe the people in your audience of the type of people you're trying to target in marketing. And then they just ask them to fill out a survey, right? So rather than going out and recruiting real people and the real audience to do a survey, you can use these agents. And I think that's a really good example of that principle, right? Like you kind of splitting it up instead of just asking in one prompt, like, is my product tagline any good or whatever. Instead you can spin up like 1,000 AIs and say, give them all different personalities that match the types of personalities you would see in your real audience, and then you have like market research on tap, right? I think it's actually a pretty solid idea. But anyway, it's just funny because I think Ritten's probably the type of person that maybe would find a way to have hot takes against AI. So I'm kind of glad that he's on our side. He's going to be having hot takes in favor of now.
Well, he's like a brand for hire, right? He's got that point where he's built his personal brand up so much that, like, 1 minute he's like advocating for TV, right? Because he's getting paid to from certain interests, and then the next minute he's like an ambassador for YouTube, which is like the opposite. and then he's like anti AI, and now invest in a company. Now he's suddenly pro AI. Like, people looking for like this like arbiter of truth. I'm like, he's just going where the money is. Like, and we're gonna do it, but like, you got to take some of what these people say with a grain of salt. There's a lot of self-interest behind. He's very good at creating his personal brand, but he's not someone I would, blindly just listen to an article and trust, that there's no sort of thing behind that. So yeah. But yeah, I like that. I was having a discussion today though with someone whose comment he deleted on this post, because he put down the end like sponsored. I have a financial interest in this startup, blah blah. Because like Joe Lombardo and the other guy from like LinkedIn, right, who started, and he's like fond of the business. Anyway, and down the bottom, like someone commented, and then like, it was just like, you're an idiot or whatever. Like, now you're shilling this whatever, and delete the comment, and then blocked him. And I was like, okay, now we're both blocked by Ritson. But I found that funny. I think the thing that probably won't die would be primary research with customers. So it can be indicative, but there's certain insights you can only find by like creating that friction through customers, because it is so fluid. So I think it has some uses for maybe testing some things or pre-testing or like getting an indicative result, but then you probably want to validate with like real research on top of that if it's something quite risky, I would say. But,
exactly. Anyway. I would say AI, the best uses of AI are when you want to do something, but it would just be basically impossible to do with your resources with the real way, right? So like if you can't afford to do market research, then doing it with AI is way better than not doing it at all, right? I find that like I had a project where we'd used the vision AI and audio transcription to ingest hundreds of hours of video from Twitch streams of people playing video games, and we found some insights of like what sort of strategies do they use, like when are they excited, when are they not excited, and that's sort of thing that can be used for product development, it can be used for marketing, and that's just it's just never nobody is going to actually do that in real life. Like nobody's going to sit there and watch 100 hours of Twitch streams, right? Even the most avid gamer isn't going to carve out the time. And like, even if they wanted to, like, imagine their boss approving that, but the AI can do it. And so like if we get any insights from that, that's a bonus, right? And it costs a few $100 instead of, tens of thousands to have people do it. So I feel like that's kind of a nice niche where like wherever there's a task that like, you're going to get some benefit, and otherwise you just couldn't have done it. Then that's when you use AI, I think.
Yeah, no, I agree. Okay, so on that, you've got a book coming out. So why don't you show us, what you got? Because I actually want to read this book because I found it sort of ironic. I was like, what are you doing? And I've had this question before. Like, what are you doing? Like releasing a book on AI, like in printed book form. I'm like, isn't this kind of somewhat ironic? But it kind of makes sense. Like, I like your strategy here. Like Jeff Bezos says, like, what doesn't change, and you've kind of written the book now, but with the forethought that, hey, what will stay the same as AI progresses and everything, and maybe some of it will like lose relevancy or whatever. But I like those 5 steps. So how do we get the book? What's it called, etc.?
Yeah. So I mean, it's interesting because O'Reilly, I think one of those publishers is still doing really well. Like the publishing world in general isn't, but because developers buy books for some, like it's kind of mad, but you wouldn't think, because developers are very tech forward, you'd think they'd do everything online, but actually what they really like is to have a reference manual, right? Like they don't have to go and look something up online all the time, check Stack Overflow or ask ChatGPT. Sometimes it's useful to get that core knowledge like have it, like you can pull it down off the shelf and flip through it, so the developers still buy books.
That's like being vetted by some sort of quality process as well, right?
Exactly, yeah, and that was the case for us. It only took about 6 months to write this, but it was a year of editing. So, O'Reilly put us through, I think it was 6 rounds of technical review, 3 people that we chose, and then 3 people that they chose. And they went through line by line, actually twice each. It was like 12 edits there. Plus we had a production editor who did 3 rounds of edits. And then a copy editor who just did all the kind of spelling, grammar, and stuff. And that was 2 additional rounds of edits. So, we've gone through this with like a fine tooth comb, and I'm sure there's probably still one spelling mistake somewhere. But yeah, like I think that's the major difference. I think doing a book with a real publisher, like in print, because the quality bar is so much higher than anything else I've ever written. I just pump stuff out there. I don't even edit my own work typically, So, I just think like, let's get the hot takes out there, and if there's something wrong, then John will tell me. With the book you can't do that. So I think that if you're looking for that condensed information, because all this information is out there, and you can learn this stuff by testing it yourself. But if you're working in AI, it's $80 US. For the book, which is very pricey, but if it saves you like 2 hours, 3 hours, and you're a software engineer, data scientist, or someone who's like kind of interested in learning more technical stuff, then that's worth your time, right? It's going to just save you, the much more than the $80 in terms of the value of your time. So that's the pitch. It's called Prompt Engineering for Generative AI.
Okay.
I have a co-author, James Phoenix, who did all the hard technical stuff, and I did all the pretty pictures and business logic principles. We kind of teamed up on that, which made it a little bit easier to write. It's out June 25th. 2024, depending on when you're listening to this. But in the US, it's already out in the UK, and it's on Amazon. Have a look on there.
Okay. I'll just buy it off Amazon unless you can ship something across the world. Cool. Okay. I think it was really good. We could probably go deeper on all of this stuff, obviously, but I think what I wanted from this episode was a bit of a crash course, and I think you delivered in spades. So thanks for filling in some of the gaps in my knowledge as well, which is really good. Are you coming to South by Southwest Sydney in October, or like what's your next speaking gig? Like if someone wants to see you, like what's the next thing that you got going on?
Yeah, good question. Yeah, I'm trying to line up a few things. South by Southwest is a good shout. I've never been. I'll look into that. But I'm going to an event in Chicago in October. Go to Chicago. That one's called. I'm going to try and do something in San Francisco, and I've got a few others in London. But if you follow me on Twitter, I'm hammer_MT. Then that's where like I post random updates and things like that. So it's probably the easiest place to find these things as they come up.
Great. I saw your post the other day about the Mario thing with the first iteration of Midjourney, and then sort of the latest one, which is Midjourney 6 or something, or 7. And I was like, wow, okay, you can really see the difference between the same prompt kind of thing. It was a Mario image or something, and I was like, oh wow,
Mario drinking.
Cool. Because I know you were using that for ages. So.
Yeah, it was Mario drinking a pint of beer. That was the first thing I ever tested with image generation. Actually, funnily enough, you try that on OpenAI and it refuses. It says, sorry, we're not allowed to do that. So. Yeah,
great. Okay, well, thanks for your time, Mike. I really appreciate it. And I'm sure if anyone has some more questions about AI, whatever, let us know. We can always do a sort of deep dive into some of these areas, depending on sort of popularity. So thanks for your time. Buy Mike's book. I'm going to buy one anyway, because I actually really want to read and get better at this stuff, because I think I made some of those mistakes that I was kind of like complaining what people say, like, hey, you got to like spend a bit more time contextualizing things and learning. And then I was like, that aha moment came. And I was like, okay, no, this is really cool. Like, I was putting in Excel data. I'm like, hey, give me a graph. And then I was like, but I want the bars centered, and I want you to label this, and blah, 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 blah. It's like super detailed. And then it's like, the wheel goes around, and I'm like, oh, it's going to be shit. And it comes back, it's like, perfect. So it's like, oh, great. Upload to social media, and then the post went viral. I'm like, oh, that was easy. I'm like, I didn't have to go to Google Sheets or anything, like insert diagram and stuff around with his axes and everything. And I was like, oh, this is so good. So
and this is the worst
awesome.
it's going to be, right? Like, in 6 months, in 12 months, it's going to be twice as good, 4 times as good. So yeah, like even if you're struggling now, it's it's going to be amazing.
So cool. Okay, well, thanks again, Mike. Really appreciate it. Talking again soon.
All right, see ya.